Hey everyone, and welcome to our lesson on factoring by grouping. This is a different style of factoring that you probably, have definitely never seen before. So I'm actually going to take you through these three examples on the worksheet you're dealing with. But before we do those three examples, we're going to do on the back just a little side example to get things started. So if you will please turn your worksheet over and write this problem down. X times the quantity of x plus 3 plus 5 times the quantity of x plus 3. Believe it or not, this problem could be presented to you and the directions could say factor. Now the style of factoring we're about to use is factoring by grouping. But here's how it would lay out for you if you were to solve this or factor it. So you see here that the x is going to be multiplied by this x and this 3. Like if I use the distributive property, this x has to get multiplied here and here. And this 5 has to get multiplied here and here. So if I wanted to expand this, I would go ahead and just distribute. But I don't want to expand it, I want to factor it, which means I want to break it up into a product of two polynomials. So here's what I'm thinking. If I think of the x plus 3, which both of these have, in my second parentheses here, then I know that this x has to get multiplied to both of those terms. So I'm thinking if I put the x here in the front, it's going to get multiplied to the x and the 3. And then this 5, this positive 5, has to get multiplied to this x and this 3. So the way this is laid out, x times x gives me x squared. X times 3 gives me 3x, and that's this right here, x squared plus 3x. Then 5 times x is 5x, and 5 times 3 is 15. And if you look here, you would have plus 5x plus 15. And so when you combine like terms, you've got x squared plus 8x plus 15. And up here, same thing, x squared plus 8x plus 15. So even though this looks a little bit different than any other style of factoring we've done, you can still reason your way through factoring it into a product of two polynomials. Okay, so just wanted to show you that as we warm up here. Let's get into example 1. So underneath the title, Factoring by Grouping, we're going to factor 3x squared times x plus 4 minus 7 times x plus 4. So the commonality here is the x plus 4, right? So the thing that they have in common, if I look at this as sort of the front end of things and this as the back end of things, the polynomial they have in common is this x plus 4. Now, the 3x squared gets multiplied to the x and to the 4. So I'm going to drop the 3x squared down here. That would take care of this distribution. And then the negative 7 gets multiplied to both the x and the 4. And so my final answer right here, 3x squared minus 7 times x plus 4. That's called factoring by grouping. Isn't that cool? Okay, let's go to the next one. And by the way, if you would check this problem and distribute, collect like terms, you're going to get the same thing as if you distribute up here. Okay, let's look at example 2. Now this one's a little bit different. They want us to factor by grouping, but this time you don't have sort of this commonality here that you can see, like the x plus 3 and the x plus 4. So we're going to do this a little bit differently. We're going to create it. So what we're going to do is we're going to group up. That's why it's called factoring by grouping. We're going to group up the 6x squared plus the 15x. We're going to bring this plus sign down. And then we're going to group up the 8x plus 20. We're going to try this anyway. Sometimes you end up grouping different things together, but I often like to try to group the first two terms and then the last two terms. Okay, so now what we're going to do, see, these don't match in any way. So we're going to factor by a GCF out of both of these quantities. So the GCF of a 6x squared and a 15x is going to be 3x. The largest number that divides into 6 and 15 is 3, and the smallest number of x's is just a single x, so 3x. And then we're going to divide each of these terms by 3x. So 6x squared divided by 3x is going to be 2x, and 15x divided by 3x is just going to be 5. Then we'll bring this addition sign down. Now the GCF of an 8x and a 20 is just going to be a 4. No x because the 20 doesn't have any x's. And if I divide each of these terms by 4, 8x divided by 4 is 2x, and 20 divided by 4 is 5. Now you can see the 2x plus 5 here and the 2x plus 5 here. So I know that 2x plus 5 is getting multiplied by this guy, 3x. See, 1, 2, 1, 2. And this positive 4 also, both terms. So there you have it. The factored version of our problem is 3x plus 4 times 2x plus 5. And we go on to our final example. So we're factoring this polynomial. So again, we're going to group up. So let's group up the first two terms, 15x squared minus 18x. Bring this minus down, and now let's group up the 5x and the 6, but pay attention here. Because I have a minus right here, I'm bringing that minus down, and now I'm opening up a quantity. I have to make sure that when I distribute this -1 through, I get a positive 6 back. So this has to change to a negative. -1 times 5x is -5x. -1 times -6 is positive 6. And now we will factor each of these quantities by the GCF. So the GCF here, well, the largest factor that 15 and 18 have in common is a 3. And they both have at least one x, the smaller number. So we'll start with a 3x. We'll divide each of these terms by 3x. This here is going to give me 5x minus 6. These x's are going to completely cancel out. 18 divided by 3 is 6. Minus 1 times 5x minus 6, because 5x minus 6 doesn't have a greatest common factor other than 1. So now we see the 5x minus 6 here and here. So I'm going to put that in my second polynomial. And in the first polynomial, I'm going to put my 3x, because I know that's getting distributed, and my -1, because I know that's getting distributed. Final answer, 3x minus 1 times 5x minus 6. So it's a little bit different, but I am able to take let's not forget the definition of factor. It's to take a polynomial and write it as a product of other polynomials. And when I see the parentheses butted right up next to each other, that is a product. So I'm doing my job. I'm factoring. All right, good luck with the mastery. See you next time.